Alright, so go to your Unit 8 packet, please. Unit 8, we're going to start talking about circuits. That means that charges are going to start moving. So on your Unit 8 packet, go to page 3, please. It says 8.1, static to current electricity. So, first question says, it has been observed that static, by the way, I want you to be writing this in your packet. First question, it has been observed that static electricity is more prevalent. Prevalent means kind of common. So it's more common during dry, non-humid days. Why do you think it is more prevalent? So the reason for that is that when it's humid, the water in the air takes away some of that charge that's building up. Alright, so static electricity is when charge builds up on an object, like when you rub your socks on the carpet and then you can zap something. So static electricity is when charge builds up on an object, but when it's humid, there's water in the air, and that water in the air is touching the object and it's taking away some of that charge. So that's why you see static electricity more when it's dry and not when it's humid. Second question here says a negatively charged object, over on the right, is connected to a positively charged object, over on the left, by a conductor. Conductors allow charges to flow. Sketch on the drawing below the movement of the electrons before equilibrium is reached. So before it stops moving, what happens to the charge? What happens to the electrons? So if this is negative, that means we have extra electrons on it, a bunch of negative charges. Electrons are the negative ones. And if we connect it to the positive ones, those electrons are all going to be attracted to the positive. So the electrons all flow, not all of them, but half of them are going to flow toward this positively charged object. So that's the direction they flow, from the negative to the positive. They're repelled by each other, and they're attracted to the positive. So they go to the left. Number 3 says a battery, that's this thing, has a positive and a negative terminal. The image of a battery is below, where the positive terminal is connected to the negative terminal by a conductor. Sketch on the drawing below the movement of the electrons. So again, the same thing's going to happen. The electrons, which are already in the conductor, because a conductor is made up of atoms have electrons. The electrons are going to flow toward the positive and away from the negative. They're repelled by the negative, they're attracted to the positive. So they're all going to flow this way, around the conductor, so that they can get to the positive side. Electrons are negative, so they're attracted to the positive side of the terminal. So they flow that way. And the fourth question says, what's the difference between static electricity and current electricity? So static, we were talking about electrostatics before. Static means stationary, something's not moving. So the charges stay where they are. Maybe they move a little bit right in the beginning, but then they just stay where they are. While current is what would happen with this battery. The charges will continuously flow, continuously move. Continuously move and flow. Alright, so that's what's going to happen in this unit. We're going to have current where charges keep going. They keep going around in a loop. Alright, so what you need to do now is go to the next page, page 4, number 5, and do this for homework. There's also more homework mentioned in the email. Alright.